Have you ever wondered how robots can precisely control tool trajectories like humans do? At the opening ceremony of the 2023 Beijing Winter Olympics, the ice cube carving robot completed a millimeter-level carving task with remarkable precision, thanks to its accurate coordinate system settings. This was truly breathtaking. Today, we will delve into this key technology, setting up the robot's tool coordinate system and user coordinate system. We will explore this topic through the following content. By the end of this lesson, I hope that you will be able to independently complete the setup and verification of the FANUC robot's tool coordinate system and user coordinate system, achieving the accuracy required by operational standards. I also aim to cultivate your sense of industrial safety responsibility, help you understand the impact of coordinate system setting errors on production safety, and instill a professional commitment to standardized operations. Next, let's move on to Task 2, setting up the robot's tool coordinate system and user coordinate system. After we create the robot's drawing workstation, the next step is to add the pen tool to it. First, click the Expand option next to the robot in the left menu to unfold it, then select Tooling and expand that as well. FANUC robots can have up to 10 tools configured. We'll choose Tool 1, right-click on it, and select Add Link. Then click CAD File, navigate to the Quick Change Tool folder, and select Pen Tool. Once Pen Tool is added to the project, right-click on UT1, choose Properties, go to the Util tab, and click Edit UTOL. This is where we modify the robot's tool center point, TCP. There are two ways to adjust the TCP. One is by directly dragging the coordinate axis, and the other is by entering the values directly. If we use the dragging method, after adjusting the position, click Use Current Triad Location, and it will automatically calculate the tool coordinate system for us. Alternatively, we can directly input the numerical values. Once the values are entered, we simply click Apply, and this will also establish the tool coordinate system. After setting up the tool coordinate system, we can conduct some tests. We can use a shortcut to move the robot's end effector directly to any desired position. To see the relevant commands, we can click the Show Hide Mouse Commands button in the menu bar, which will display some command prompts. If the robot's end effector can successfully reach the target position during the test, that means our tool coordinate system has been set up correctly. Next, let's set up the user coordinate system. Expand the user frames under the robot directory in the left menu. The default workpiece coordinate system, frame 0, is the world coordinate system, which cannot be modified. Therefore, we can only start modifying from user frame 1. Select UF1, right-click, and choose Properties. In the tab, there is an option called Edit UFrame. Check this box, and a plane will appear. This plane represents our user coordinate system, also known as the workpiece coordinate system. We can drag this plane to adjust the position and orientation of the coordinate system, and the corresponding data will be updated in real time. Another method is to use the TCP for confirmation. We can demonstrate both methods. First, reset to the default position. After manually adjusting it, click Apply, and the user coordinate system will be established. This is the first method. The second method involves using the robot's TCP to determine the position. Let's conduct a test. By default, we select a specific position and move the robot to the location we want to use as the origin of the user coordinate system. Click Use Current TCP Location and then click Apply. This completes the setup of the user coordinate system. However, at this point, the orientation may not be correct. We need to rotate it by 180 degrees. Simply enter the rotation value and click Apply. This completes the establishment of the user coordinate system. After setting up the user coordinate system, if we need to return the robot to its home position, there is a shortcut. Click Lock Unlock Teach Tool selection in the menu bar. The current coordinate values will appear at the bottom of the screen. Change the coordinate property to joint coordinates, reset each axis to its initial position, and then press Enter on the keyboard to confirm. This will return the robot to its initial state. With these steps, we have successfully created both the tool coordinate system and the user coordinate system. Next, I'll conduct a simple test to check your learning outcomes. Please try to set up a tool coordinate system and a user coordinate system based on what we just learned, and then verify them. Here, I'd also like to share a case with you. A factory experienced a robot colliding with equipment on the production line due to inaccurate robot coordinate system settings, resulting in significant economic losses and safety hazards. This case illustrates that standardized operations and accurate coordinate system settings are crucial for ensuring production safety and efficiency. Therefore, in your studies and future work, it is essential to develop a professional habit of standardized operations and always keep industrial safety responsibility in mind. In this lesson, we have mastered the methods for setting up the tool coordinate system and user coordinate system for FANUC robots, and we have practiced and verified these settings. We have also deeply understood the importance of coordinate system settings and the impact of errors on production safety. Lastly, I hope you can become proficient in setting up tool and user coordinate systems and strictly follow operational procedures and safety requirements in future practical operations. Thank you all.